Good evening, everyone. Uh, Myself Yashvi Sheth, and today this is the second live session on the course Basic Calculation Principle and Calculations in Chemical Engineering, taught by Professor Subrato Majumdar from IIT Guwahati. So now we can start the session. I will share my screen. Firstly, in this second live session, we will be starting with the brief of the lectures that were taught uh, in the second week. So, moving to the brief of lecture 4, basically the entire lecture 4 covers various definitions and various important terminologies that are usually used that you will be using during throughout your career in chemical engineering. So being a chemical engineer, these are the most basic definitions you should focus on. So first definition that was important and highlighted in the lecture was the state or thermodynamic dynamic variables. So for um, any material or any substance or any process going on, there will be some certain variables or the thermodynamic variables that are related to that thing. So now for that particular system, those thermodynamic variables usually include temperature, pressure, and all the other variables like internal energy. Just a second. Enthalpy, etc. Now, why these properties are termed as state variables? Because they do not depend on the path of the system. So for example, if you have a system in which there is one stream going in with T inlet, pressure inlet, and there will be some outlet which is having temperature outlet, pressure outlet. Okay, so during the entire process there can be number of steps involved, but whatever may be the process, the it will not depend on what path you have taken. It will just depend on what are the outlet variables. For example, the internal energy will be just the function of temperature and the pressure, and not how you have gone from one step or one process to another process. So these type of processes are known as state processes and state variables. Now there are some other variables known as dynamic variables. These dynamic variables, the value of these dynamic variables change, or we can manipulate the value of these variables. So such variables are example of these variables are inlet and outlet flow rate. This is just one example. Apart from that, there can be geometric variables also. Now, as the name itself suggests, geometric variable, it is related to the dimensions or the configuration uh, of the any of the instrument. So, suppose you have a pipe in which you have water flowing. Okay, so the length of pipe, the diameter of pipe, or instead of diameter, you can even say the cross sectional area of the pipe. All these variables, so length, diameter, height also, they represent the geometric variable. Okay, now another is the physical property. So these physical properties are the properties which we tend to measure of any material or of any substance. or any chemical species which is independent, like which we are able to measure. So for example, density, viscosity, conductivity, or any such thing which we are able to measure externally without changing the state or without changing the form of the chemical. Suppose you have a solid, and if you want to measure the density, then by measuring the density you will not change the form or change the state of the chemical substance or any solid. So that is a physical property. Next comes is, what do you mean by a system? Okay, so what is a system? So, say for example, you have, this is a process in which raw material is being processed. So this is the inlet, this is the outlet. Now this goes to a reactor. Two types of products. This is gaseous product. Let's say this is the another product which is having byproduct plus product. So this is the separator and this is the final product. So when you are doing any calculation, this can be your system on which you are doing the calculation, so that you are not considering any other part. So for now, it can be just your simple. This just can be your simple system, or when you are doing for this part, it can be your system, or this also can be your system. Or when you are doing total mass balance, this individual systems will be considered when you are doing individual or component wise mass balance for a particular system. There will be overall mass balance also. So in that case, you will consider entire system in which total inlet, total outlet will be considered. So entire system will be considered. So what we choose as a system, it is a arbitrary portion, which can be just a fraction of the entire process, or it can be the whole process as I mentioned here. So it is on which we try to solve the problem, or we try to do the analysis of the problem. So it is defined as the system. Next comes the intensive properties. Now, intensive properties are the physical properties of any system or of any material which do not depend on the amount of material present in the system. Say, for example, temperature. So, if you have some liquid filled in a reactor and you are mixing it, so the temperature of all the entire liquid in the system, in the reactor, will be constant. Now this temperature, it will not depend on how much amount of liquid is present. Now, so this temperature is intensive property. Suppose this is the reactor with T initial, and now you want to take it to some T final. Okay, so this transition will require addition of some heat. Okay, now this heat you have to add in some form of energy by heating the system. Okay, and for that, the amount of energy that will be required will depend on the mass of, or the amount or the quantity of the material present. So the amount of heat or the amount of energy that will be required to raise the temperature, it will depend on the mass of the material, because lesser the mass, lesser will be the amount of energy you will feed to raise the temperature. So such type of properties like energy or volume, it depends on the amount of material. So those are termed as extensive properties. Next comes the transport property, which are the properties indicated by the molecular properties. Okay, so such proper transport of the molecules. Okay, so such properties are rate of momentum transfer or heat transfer or mass transfer. So these are the major transport properties which are observed. Next comes the terminology, which is the most basic one. It is, you must have learned it before also, which is mass concentration. Now, mass concentration is usually measured with respect to volume. So, how do you measure? So, mass concentration is the ratio of the mass of any substance So mass concentration is the ratio of mass of species A divided by the volume of system or the volume of solution any you take. So that will be the that is the mass concentration. Now say if you have mass fraction, so for that what you will do is, suppose you have a system in which there is A plus B. So to find out mass fraction, uh, let's say A has MA mass, B has MB. So the fraction of A present in the entire system will be MA divided by the total amount of mass, that is MA plus MB. Now if this is just an example for two components in a system, if you have A plus B up to like N, okay, so in that case, to find out the mass fraction of any species I, so it will be Mi, that which is the mass of species I present in the system, divided by the total amount of mass of all the components. So that will be the summation of Mi over from Mj, from Ij equal to 1 to n, which is the total number of species. So this is the mass fraction of species I when there are n components. Now next terminology that we encounter frequently will be the mole fraction. So similar to mass fraction, here we have, for calculation of mass fraction, here we have considered mass as the uh, uh, mass. Here we have considered mass. So to calculate fraction, that is mole fraction, we will consider, what we will consider is moles, which is the number of moles. So for example, in the same system A and B, suppose Ma and Mb is the mass present of A and B respectively, then for A, number of moles will be mass of A divided by molecular weight of A, and for B it is Mb by Mwb. So which is represented as, let's say, Xa and Xb. So mole fraction of A is equals to moles of A divided by the total number of moles, which is Xa plus Xb. Now, similar to the previous question where you, previous system where you have more than two species, that is, let's say if you have n components, then in that case, mole fraction would be equals to Xi divided by summation of all the number of moles, from summation from j equals to 1 to n Xj. So this is the mole fraction when you have n number of components. Next comes is the definition is specific gravity. So specific gravity is usually used term when you want to compare the densities of two materials. Say for example, if you have oil and if you have water. So water is usually considered as the reference material uh, because water is the universal solvent and also its density is 1000, that is 1000 kg per meter cube, or it can be 1 gram per cc. Okay, so what we do is to find out the specific gravity, we will take the ratio of density of oil. If you want to take the specific gravity of oil to the density of reference material. So usually what reference we take is water. Next comes is, if you have a mixture of gas, liquid or solid, then what will be the density of the mixture? So to find out density of mixture will be, what is density? Density is mass upon volume. So for mixture having gas, liquid and solid, the mass of, let's say, gas is mg plus liquid is ml. Here it will be total, okay? Liquid mass and mass of solid divided by volume of gas plus volume of liquid plus volume of solid. Now if we divide individually, mg by vg plus vl plus vs plus ml by vg plus vl plus vs plus ms by vg plus vl plus vs. So here now for individual fraction, since it is mg we will multiply and divide by vg. Okay, so vg into mg by vg into vg plus vl plus vs. Now mg by vg is nothing but the density of gas, and this term Vg by Vg plus Vl plus Vs, this term represents the volume fraction of gas in the entire system, which is represented by alpha G. So similarly, if we solve for liquid and solid, the term which we get will be rho G rho m equals to alpha G, that is the volume fraction of gas in the system, into the density of gas, plus volume fraction of liquid in the system into the density of that liquid, plus the volume fraction of solid into the density of solid. So this is how you derive that equation. Next comes is the viscosity. So viscosity is the term. It defines as the resistance that is offered by a fluid to flow. Now this fluid can be gas also, or it can be liquid also. Now how does it offer the resistance? Suppose you have a liquid in flowing in between the pipe, so there will be layers of molecules which are passing through it, so it will try to stick onto the surface, so there will be some force of adhesion with the walls and in between the layers of the liquid that are flowing also. So that adhesive force which is present, suppose you have two layers, then there will be some adhesive force So for the flow to occur, this adhesive force, like the force in this direction, has to be greater than the adhesive force which is in the opposite direction, uh, restricting the flow of fluid. So this forward force has to be greater than the adhesive force. So viscosity is the constant which represents the adhesive force, which is if mu, that is the viscosity, is higher, it represents that the fluid has higher adhesive force between the layers. And so for fluid to flow, we need to apply more force or more energy for it to flow. Now, if we take the example, then we have oil and water. Then oil, if you have seen, it is having more viscosity. So water flows very freely because its layer are not that much sticked due to the adhesive force, and that is why if we just shake it, it will flow. And apart from that, if we have oil with us, the layers are more attached to each other through adhesive force. So the flow of oil, especially castor oil, it is very difficult to flow. So this is how viscosity is defined. Next comes is the brief of lecture 5, in which mostly the pressure of fluid pressure is discussed, and how do we measure the pressure is discussed. So say for example, this is the system in which you have this much amount of liquid. This is the liquid. It has density rho. Now since it is open to the system, this pressure would be atmosphere, or if it is covered, then let's say it has some pressure P naught. Okay, so that much amount of pressure will be exerted. Now this is liquid. Now as you know, liquid has some mass m. Okay, and due under the influence of gravity, this is the force gravity acting in the downward direction. So if liquid has mass m, so the force which is acting in the downward direction due to gravity, it will be m into g. M is the mass of liquid. Okay, now if you want to represent this m, and if you want to convert this force into pressure, now as you know, force and pressure are directly connected. So pressure due to this liquid present in this section will be force per unit area, which is this area on which it is acting. Now F is equals to mg and area is this. Just a second. I request you to please mute yourself. Yeah, so I was continuing with this. Like force equals to mg, and area here on which the force is acting is A. Okay, now we can replace this m in terms of density of the fluid by since rho equals density equals to mass upon volume, m can be replaced as V rho into V into G upon area. Now this volume is the volume of the liquid that is present, that is equal to, now liquid is present in the entire area, which is this area, and it is for height h. So the volume of liquid will be A into H into rho, which is already present, into G divided by A. Now if I cancel this out, A, what remains is rho G H. Now this much amount of pressure, that is equals to pressure. So this much amount of pressure, which is equals to rho, which is the density of fluid, into the gravitational force, into the height of the liquid column or the height of the liquid which is present in this system. That much amount of pressure is due to the liquid. Now the total pressure at this point will be what? P equals to P naught, this much pressure plus pressure due to this. So that will be equals to rho g h. So this is the pressure acting at the bottom of the tank. Now there are various terminologies that we use, and there are various reference points also. So we can measure pressure in terms of atmosphere, in terms of bar, in terms of mmHg, in terms of psi, etc. There is one more terminology which is gauge pressure. Now this pressure is usually measured with reference to the atmospheric pressure. So say for example, if you have pressure that is existing is equals to 3 atmosphere. Now if you want to measure it in terms of gauge pressure, then the atmospheric pressure needs to be deducted. That is 1 atmosphere. So the gauge pressure for this system equals to 3 minus 2 to gauge. Okay, so this is how you calculate gauge pressure. Next important terminology that was highlighted in the lecture is standard temperature and pressure. Now usually there are many properties, say for example entropy, enthalpy, Gibbs free energy. These are just few examples. Now these are few examples. Now these properties, they depend on temperature, pressure of system. So we need one standard point at which we measure, and that will be considered as the standard. Say for example, if you take enthalpy H or let's say G, then the standard temperature and pressure is 273 Kelvin and 1 bar, at which we measure the value, and it is denoted by naught, G naught, H naught. Okay, so naught represents here the standard temperature pressure values. And now if you want to measure at any other temperature or pressure, then there will be it will be easier to relate, because we can do experiment and we can find out the correlations on how do we relate, say for example G at any temperature T with so we will be able to just a second. So we will be able to relate this G, which is at any temperature, random temperature T, with respect to the G naught, because we will be having a function which is Gt as a function of standard this, and we can have terminologies which is T, so that we can find out what is at any temperature T. Next is how do we measure the pressure of any system? So for that, we have a pressure measuring device, which is the manometer, as highlighted here. So this is a most common manometer which is used, and so for example, this is the fluid which is filled in the manometer, and we have a fluid which is having higher density, so that the amount of liquid which is required, because as you know, the pressure exerted by any fluid is rho gh. So higher the density, for same pressure, lower height will be required. So lower amount of liquid to be required, we use mercury as in many cases in YouTube, in this manometers. Okay, so how does this manometer work? Say for example, this you have a YouTube manometer. It is having row 3. So if you supply some pressure here, P1, and this has pressure P2, also this pressure P1 is external, there is some fluid which is flowing, and it has some density rho 1. Here also there is some fluid which is having density rho 2, and this is the uh, fluid through which we measure the pressure difference or the pressure. Now suppose this P1 is greater than P2. So now since pressure is related to force, higher pressure means more force you are applying on unit cross section area. So for same cross section area, higher P1 means you will apply more force here, and it will result into the travel of this fluid through the entire U-tube, and it will shift this liquid upwards. So now there will be certain pressure exerted due to this also, like this also has some pressure. So until and unless both the pressures are, now more you shift, this also will try to shift the liquid here. So the system will come into equilibrium when the pressure at a certain point, say for example this is the reference point, then the pressure exerted due to the entire upper portion or the upper system here, which is P1 plus rho 1 G H1, and here it will be P2 plus rho 2 G H2 plus H rho 3 G. So this is the pressure on the left limb, this is the pressure on the right limb. So until and unless both the pressures are equal, there will be a shift and there will be some equilibrium attained. So based on that equilibrium and the shift in this height h, we will be able to measure rho gh, and we will be able to measure how much amount of pressure is exerted due to any liquid. So till this point, do you have any doubt? If not, I will continue. Now moving forward to the brief of lecture 6, it usually in this lecture it is majorly covered in terms of rate of any thing. So first rate that was highlighted was the flow rate. Now rate means, flow rate means it can be anything, amount transported per unit time. Now this amount can be represented in terms of mass also, and it can be represented in terms of volume also. Okay, so if it is mass per unit time, then it is mass flow rate, and if it is volume per unit time, then it is volumetric flow rate. Now since mass and volume of anything is interrelated by density, that is density equals to mass per unit volume. So if you want to convert mass flow rate into volumetric flow rate or volumetric flow rate into mass flow rate, then they are interlinked. So say for example, if you have mass flow rate m dot, and if you have volumetric flow rate given, if you want to convert it into mass flow rate, then mass flow rate equals to volumetric flow rate. Now mass equals to volume into density. So if I do rho v equals to m, so now flow rate is with respect to time. So m by t will be rho, since rho is constant, it will remain as it is, rho into v by t or delta t, delta m, it will be delta. So this is nothing but flow rate, that is volumetric flow rate. So volumetric flow rate into density. This is how they are related. Now comes to the transfer of heat by conduction. What is the meaning of conduction? That I had already highlighted in the previous lecture or the previous live session. So conduction briefly is nothing but the energy transferred due to the vibrations of molecules and the collision. Now due to this collision, there will be some amount of energy that is transferred. Now what is the amount of the energy that is transferred due to this collisions? So say for example, if you have a wall, it is having, on one side of wall it is having temperature T1, another side it is having temperature T2. So with temperature T1 greater than T2, and there will be some molecules. So due to the vibrations, due to the temperature difference, there will be transfer of energy from T1 to T2. And what is the rate of this energy transfer? It is represented as Q dot. Now this Q dot, this transfer of energy, it will depend on the temperature difference. Firstly, because more the temperature difference, more will be the gradient. Okay, it will depend on the temperature gradient here. Now what does the gradient mean here? Because there is some distance to be traveled also. So more the distance, lesser the amount of heat will be, or more time it will take for the heat to travel or the heat to flow. So the rate of heat flow will inversely depend on the distance between two. So this entire term is denoted as temperature gradient. So the gradient of any term is nothing but, so that difference in the term, say for example that property is x, delta p, that property is p, delta p by the difference in the distance. So that distance is, let's say, x. So change in the property with respect to the length is gradient. So this is the gradient here, which is temperature gradient, and also the cross section or the area through which the heat is flowing. Say for example, here there is some insulation, so this amount of portion, it will not allow the heat to travel. Okay, so Q also directly relates to the area through which the energy is traveling. So now to eliminate, and if we club these two proportionals, and if we want to eliminate the proportionality constant, then there is a constant which is thermal conductivity. So this K into A delta T by delta X, or here which is the length of the material through which it travels. So this is the Fourier's law, which allows us to find out the rate of heat flow through any solid medium by conduction if it has some length L and temperature difference delta T, which is equals to T1 minus T2. Now here the minus sign represents because the travel of heat is in this direction and L2 L1, so the distance is L2 minus L1, and T1 minus T2 has to be there because the gradient is in this direction. So that will be minus. Next is convection. So heat transfer by convection is majorly observed in fluids, which is due to the bulk motion of the molecules. Say for example, this is the hot block at temperature with its surface having temperature Ts, and far away there is air in contact to this surface, and the temperature of the bulk, which is very far from this hot block, it is having temperature Tf. Now there will be some amount of molecules which is in contact with the surface of this, which is in the immediate contact of this hot block surface. So that layer of the molecules will have temperature Ts, and it will be having more amount of energy. Okay, so the vibrations will be more. So this temperature will lead to the change in the density of these molecules. Now as you move upward, the temperature has this profile. Okay, because far away it is having Tf. Now gradually it is increasing because this surface temperature is Ts. So this is how it follows the trend. So now as the temperature of this surface, the surface of molecules which is in immediate contact with the hot block increases, it tends to travel upwards because of the decrease in the density, and the cooler layers they travel downward, and again they get heated. So in this manner there will be a bulk motion of the molecules or the layer of molecules that will occur, and the temperature will be transferred or the heat will be transferred in terms of temperature gradient by the motion of the molecules, which is due to the density difference. So the density of this molecules which is far away from the hot block, it will be the lowest, no sorry, it will be the highest, and the temperature will be lowest. So these molecules tend to come downward, and the temperature in the immediate vicinity of the hot block will be highest, so density will be lowest and it will tend to travel upward. So this type of difference in the density will cause the molecules to flow, and this motion is nothing but bulk motion of molecules, which will lead to the heat to flow from hot block to the air. Now what will be the amount of heat transferred per unit time, which is nothing but the rate of convective heat transfer, Q dot. It nothing but depends on the temperature difference. Okay, more the temperature difference, there will be more amount of density difference and more amount of transfer will be there. So it will nothing but depend on the temperature difference, Ts minus Tf, and also the area, because more the area of hot blocks or air is exposed to each other, more will be the transfer. So Q convective also depends on the area. Now to club these two equations and remove the proportionality constant, this convective rate of heat transfer equals to H A delta T, where delta T is Ts minus Tf, and H here is the convective heat transfer, which is nothing but the overall or convective heat transfer, which is here the proportionality constant. Now another form of transfer of energy can occur in the form of radiation, where the heat is transferred in the form of photons or waves. So more the temperature, more energy will the photons have, and more amount of radiations will be transferred. Now this radiations, for photons to transfer, we do not require any medium. So radiation can be do not require any medium to transfer. The best example of this is the transfer of energy from sun to earth, because temperature of sun is much higher than temperature of earth, and also the distance is very large with vacuum here. Since also it does not have any medium, also the energy will be transferred in the form of radiations from higher energy, which is Ts, to lower energy, Te. Next comes as the transfer of any material or any species, so which is highlighted in the terms of diffusion. So for any movement of any substance, if you have a barrier here, if you have A plus B, but there is Ca, Cb, Ca, Cb. Now, if you remove the barrier, and if Ca here Ca1, Ca2, Cb1, Cb2. So here Ca1 is greater than Ca2 and Cb2 is greater than Cb1. So there will be net transfer of molecules from one place to another, which is Ca1 will transfer from this to this and Cb2 will transfer from this to this. So this motion will be from higher concentration to lower concentration, which is in the direction of the gradient. So what will be the gradient here? The gradient will be delta C per unit distance. Okay, so gradient here is the concentration gradient. Now, this is the diffusion where you do not supply any external motion. Okay, so how is it related with if you supply with some external motion? So say for example, this is the very common example. If this is just pure water, now if you add sugar granules or sugar crystals to it, so these are these sugar crystals. So this is rich in sugar, which is solute, and pure water does not have any solute. So there is a large amount of concentration gradient. So there will be transfer of this or the dissolution of this sugar molecules to the liquid phase. Now this transfer of molecules is due to the diffusion. Now if you provide any external stirring, okay, so more you stir, the more the granules will, or the crystals will be stirred in the water, so faster will be the dissolution or faster will be the mixing. Now this, what does this mixing mean? You are applying some turbulence which can be termed as eddy diffusion, which is due to the external mixing or external bulk movement that you provide. So the more rigorous mixing you apply, the faster will be the sugar crystals to mix in the pure water. So there is one term which is diffusion, which does not include any external bulk movement or which do not require any external agitation, and there will be another external bulk movement. So the bulk movement, it adds up in the mixing, and the overall net mixing or the transfer of molecules, net movement of molecules, it enhances a lot because diffusion coefficient is much less than this the diffusion coefficient which will be due to the bulk transfer or the bulk movement. So we here take one mass transfer coefficient, which is the overall mass transfer coefficient or the total mass transfer coefficient, which takes into account both diffusion and the mass transfer due to the bulk movement also, which is supplied by external force. So which is represented by Kc and the concentration gradient. So this is the equation for this system where you have some concentration at the surface and some concentration in the bulk. So the flux or the net transfer of mass will depend on diffusion plus bulk motion, which is totally known as Kc, which is total mass transfer coefficient. Now next comes is for the reaction. Now the rate of reaction, say for example, if you have A plus B gives products, then the rate of reaction is either it is the decrease in the concentration of reactants, either of the reactant, or increase in the concentration of product, any of the product. So for example, if the reaction occurring is A moles of A reacts with B moles of B to give C moles of C, plus d moles of D. So here the rate of reaction, which is, it is proportional to the concentration of the reactants added. Now this relation or the proportionality can be any power. Say for example, it depends on the concentration of A with power x, and it depends on the concentration of B with power y. Now this power can be any arbitrary which needs to be calculated from experiment. It might be same as the coefficients of A and B coefficient, but it need not to be same as the coefficient. So x and y may or may not be same as A and B. Now here x and y are termed as the order with respect to A, like x is order with respect to A and y is the order with respect to B. Now this x and y represent, say for example, like how will the rate of reaction rate will progress, or the reaction will proceed with respect to the concentration of A. Say for example, if you have reaction A plus B gives C and R equals to, it is proportional to A power 2 B power 0. So now if you have initial concentration of A equals to 2 and initial concentration of B equals to 1 molar, so rate will be proportional to 2 molar square and 1 molar power 0. Now if you change the concentration, or if you want to increase the rate, or if you want to decrease the rate, then you can manipulate any of this. Now for example, here the rate is independent of the concentration of B and it is dependent on twice the like the square of the concentration of A. So now if you want to increase the rate, then you can, what you can do is you can increase the concentration of A and it will the rate will increase 4 times. So if you double the concentration of A, let's say if you double it to 4 molar, then what the increase in the rate will be 4 square, it will be 16 times. So it depends on the square. However, if you do from B equals to 1 molar to even if 5 molar, then there will be no change in the rate. Okay, so this is how it determines the rate. Now, if you want to see what is the overall rate of the overall order of the reaction, then it will be x plus y. And here x is the order with respect to A and y is order with respect to B. So do you have any doubt till now? Anyone? So if not, I will move to the assignment solving. So here the first question is, which one of the following is an example of extensive property? So as I mentioned, extensive property is a property which depends on the mass or the amount of material or amount of substance that is present. Now here if you look at the options, then pressure, temperature, density and mass, then mass is the correct answer because it actually depends on what is the quantity. Okay, now density is a constant term, pressure and temperature are also constant terms. It do not depend on whether you have taken 5 grams of any material or you have taken 10 grams of material. The pressure in the system exerted due to that much amount of quantity, the temperature of in that material or the density of that material, it will be independent of the mass. So here the correct answer is mass. Next question is, which one of the following is not an example of transport property? So transport property is as the name suggests, it is due to the motion or due to the transfer or transport of any material or any molecules. So if we look at the definitions, conductivity is the measure or the ability of the transfer of ions to move. So how do we measure conductivity? It is due to the motion of ions in any solution. So the conductivity is also a transport property. Now chemical durability. Chemical durability is nothing but the resistance of any substance to change because it is durable. Now if you take the example of iron rod, now chemical durability, one of the most common example is the corrosion, because here there will be some amount of transfer of ions, electrons or anything which will cause the rusting. So here it is not durable. So the most common example is corrosion. Now density. Density is the ratio of mass to volume. So it is not involving any transfer or transport of material. So it is not a transport property. Another also we need to check, which is permeability, which definitely relates, it is a constant which is the measure of the ability of any fluid, gas or liquid to pass through any substance. Okay, so here the correct answer is density, because it does not relate involve any transport of material. Next question is a solution of specific gravity 1 consists of A 35, A which is having weight percent 35 and remaining is B. The specific gravity of A is 0.7 and the specific gravity of B is dash. So to solve this question, firstly what we need to do is, we have A as 35 weight percent, so rest is B. So the total weight fraction or weight percent will be what? Like what has to be the total weight percent? So A plus B has to be 100%. Okay. So since A is 35%, the weight percent of B would be 100 minus 35, that is equals to 65%. So in a mixture, you have 35% A, B is 65. Okay. Now, to solve this question, we will take a basis. Since the fraction is in terms of weight, so the basis we will take in terms of weight. Okay. So let's say you have 100 grams of mixture, which is A plus B. Now 100 grams of mixture means it has 35% A and it has remaining 65% B. So 35% of 100 grams is nothing but 35 grams of A, and 65% of B means 65% of A, 65% of 100 is 65 grams of B. Now here we are given with specific gravity of A. Now specific gravity of A means 0.7 means 0.7 by density of water. Now density of water is nothing but 1 gram per cc, because here we are dealing with gram, so which is 1. Sorry, here it will be density of A. So density of A is nothing but specific gravity of A into density of water, that is 0.7 into 1, that is 0.7 gram per cc. Now now we need to, I had given one equation which is rho m equals to the volume fraction of A into rho A plus volume fraction of B into rho B. Okay, so here but we don't know the volume fraction, but here we have taken weights and we know the density of A. So the mass of A present in the mixture is 35. So we can calculate the volume, which is VA equals to mass of A divided by density of A, which is 35 grams per zero point 0.7 gram per cc. So can you calculate and tell me what is the answer of what is the volume of A in the solution? You can unmute and tell me. Uh, has someone calculated? So if not, 35 by 0.7 comes out to be 50. So this is 50. cc is nothing but centimeter cube or ml. So volume of VA, like A in the mixture is 50 ml. And for B, we need to calculate. So the mixture density is 1. So here the total mass is MA plus MB upon total volume VB, which is 1. So this total is 100. Now we know MVA, which is 50, plus VB is to be calculated, which is equals to 1. So VB comes out to be, if someone calculates, VB comes out to be 50 only, right? 50 ml. Now, to calculate the density of B, density is MB by VB. So, weight of B is 65 in the mixture and volume of B is 50 in the mixture. So, the density comes out to be 60 by 50, which is 1.3 gram per cc. Now, to find out the specific gravity is nothing but rho b by rho w, which is 1.3 gram per cc by 1 gram per cc, which is nothing but 1.3 gram, 1.3. So the specific gravity of B here is 1.3. So 1.3 is the correct answer. Any doubt so far? So if not, we can move to the next question. Here it says that in a binary mixture of A and B, the weight fraction of component A will be more than the mole fraction of B if the ratio of molecular weight of A to molecular weight of B is dash. So for that, what we are given is weight fraction of A means, let's say we have WA is weight of A, WB is weight of B. So weight fraction of A is nothing but WA by WA plus WB. Now it is more than the mole fraction of B. Now mole fraction of B is what? Moles of B upon total number of moles. Here N represents the moles of any species, like this is the moles of B and this is the moles of A. Now if we want to simplify, moles of B is nothing but WB divided by molecular weight of B, which is MB, divided by total divided by WA by MA plus WB by MB. If we simplify this further, so WA by WA plus WB is greater than WB by MB divided by MB WA by MA plus WB MA, and here it will be MB. Now MB gets cancelled out here, and if we simplify it, it will come out to be WB by MB by MA WA plus WB. MA will get cancelled out. So this is the relation. Further, if we simplify, then this comes here. Then WA into MB by MA, WA plus WB is greater than WB into WA plus WB. So further simplifying will give me WA square MB by MA plus WA into WB will be greater than WB into WA plus WB square. So since it is inequality, we cannot cancel out as such, but we can subtract WA WB on both the sides, and so ultimately it will get cancelled out. So what remains is WA square MB by MA is greater than WB square. So if we further solve this inequality and rearrange, then WA by WB the whole square is greater than MA by MB. So this means that molecular, this is the ratio which is like WA by WB. Since the weight fraction is more than this, like WA is more, then this ratio will be greater than 1. Okay, and that is why the MA by MB, like if you take square also, it will be more than 1. So, like, sorry. WA by WB whole square is greater than 1. Now, since this is greater than 1, so we can, and MA by MB is less than this term. So we can say that MA by MB is lesser than 1. So the answer here is less than 1. Next question is, dielectric material has what type of electric conductivity? So dielectric material is nothing but an insulator. So it does not allow electricity to pass, and so it has a poor electrical conductivity. Next question is, permeability can be determined by Q equals to this equation where these terms are given. Now, permeability is the transport of mass from high concentration to low concentration, which is due to the concentration gradient. Now, concentration can also be related in terms of pressure. So, this transfer will be from high pressure to low pressure. So, the correct answer here is fluid will flow from high pressure to low pressure. Next question is, which of the following is not correct? 1 atm is equals to dash. So if you like, you need to remember the conversions of one unit to another unit. So 1 atmosphere is equals to 1.013 bar, which is correct. Okay, it can also be represented as in terms of Pascal, which is 101325 pascals. 101325 pascals. Or it can be also represented as 760 mmHg. Sorry to disturb. Yeah, so it is also 1 atmosphere is also equals to 760 mmHg or 760 torr, or it can also be 14.6 psi. So these many conversions can be done. So here this is also correct, this is correct, this is correct. Now if you want this is in terms of Pascal only, but it has kilo ahead of it. So if you want to convert 1 atmosphere equals to 101,325 Pascal, now this Pascal into kilopascal, so you need to divide this term by 1000 because kilo represent a multiple of 1000. So this will be divided by 1000. So 101,325 by 1000 is nothing but 101.325 kilopascal. Okay, wherever here it is mentioned as 10.13, which is not correct. So this, for this question, the answer is 10.13, which is not the correct answer, like which is not the correct conversion of 1 atmosphere to kilopascal. Next question here is, a manometer utilizes a fluid having dash density than the other liquids in the processing unit. So for this, I already mentioned in the previous slide that we usually use the fluid which is having higher density because the pressure due to fluid will be rho gh. Now higher the rho, like the change in pressure we will measure as delta P, which will be obtained in terms of the height difference of the fluid. Okay, so if this density is high more, then we require lesser amount of fluid. So which is why we take the density of fluid to be higher. So this is how a manometer operates, and this for the atmospheric pressure and the pressure to be applied, there will be a rise in the fluid, which is, so this height h will relate to the rho gh, which is the imbalance in the pressure. So this delta P will be obtained in terms of the height of this fluid. So to use lesser amount of fluid, we take higher density fluids. Next question is, the right limb of a simple U-tube manometer containing mercury is open to the atmosphere, while the left limb is connected to the pipe in which the fluid is of specific gravity 0.9. So here the fluid is having specific gravity equals to 0.9. Sorry, 0.9. Also, the center of the fluid is 12 centimeter below the level of mercury in the right limb. So this is the center. Find the fluid pressure in the pipe if the difference in the mercury level in the two limbs is 20. So this difference is given as 20. This is the mercury level. So for calculation, we need to have a reference point. Let's say this A is taken as the reference point. And we need to check what is the pressure applied due to this and this on both the points, and we need to have equal pressure because it is having same level. So pressure on left has to be equals to pressure on right. So what will be the amount of pressure which is exerted on left side? It will be due to this liquid also. Let's say pressure liquid plus the height of plus the liquid having this much height, rho of let's say this liquid is L, so rho of liquid G H. Okay, and on the right hand side, since it is open to atmospheric, the pressure exerted here is pre-atmosphere. So P atmosphere plus the pressure due to this much height of mercury, rho of mercury, G H of mercury. Now you need to find out this pressure PL. which is nothing but atmospheric pressure is 101,325 Pascal. You always keep the units in SI so that it is easier to calculate and there is no confusion, because you cannot add or subtract the terms which are having different units. So let's say this is in Pascal. So try to keep everything. Pascal is, since an SI unit, try to keep everything in SI. So here rho of mercury is 13.2. It has, mercury has specific gravity equals to 13.2. Now if I want to convert it into density in kg per meter cube, so I will multiply it with 1000, because that is the density of water at normal temperature, into 1000 into G is 9.81 into height of mercury here is 20 centimeter. So 20. Now since it is in centimeter, we will convert it into meter by, okay, so divided by 100, and also we will, this term will come on the right hand side, and it will be density of liquid is given in terms of its specific gravity, so 0.9 into density of water is 1000 into 9.81 into the height of this is 20 minus 12, which is nothing but 8. So it will be in centimeters. So 8 by 100 meters. So if I calculate and solve this, then pressure in the pipe will be, if you calculate, can someone please calculate and solve and tell me? If someone gets the answer, then they can unmute and let me know. Anyone? So the answer actually comes over here is 127152, but which is Pascal, or Pascal is nothing but Newton per meter square. So there is some mistake in the options. So actual answer is this much. You can get somewhat near to this question, near to this value. More or less it should be same, but not, no option matches here, so you can correct this one. Going to the next question. An inclined tube manometer is dash sensitive than a U-tube manometer. So for the, and to answer this question, we will first understand the mechanism of an inclined tube manometer. So for example, if you have this tank and there is this much pressure difference, which is in terms of height h1, it will cause this fluid to flow in this direction. So the actual pressure is in the direction L. Okay, and let's say this tube is having, or it is making an angle theta with the horizontal. Now actual direction of force is in this direction. However, the height will be, suppose if you have just vertical manometer, then it will be represented by h2. However, since there is some theta, then this height will be nothing but, let's say if this is x, sorry, then sine theta will be h2 by L. So the length here, or the force, the length here will be magnified, because it will be h2 by sine theta, and since sine theta is always less than 1, then this ratio will amplify. So for any cases where we have very minute change in pressure also, then the if we have just U-tube manometer, then the corresponding change in height will be h2. But since we are inclining this tube, then the displacement of the liquid and the height, it gets amplified, and that is why this inclined tube manometer is more sensitive, and it is usually applied where we need to measure very small amount of pressure difference also, because that small amount of pressure difference also amplifies the change in the height. So here the correct answer is inclined tube manometer is more sensitive to the as compared to the U-tube manometer. Next question is, which of the following is not correct, or it is not the correct conversion for temperature to different units? So here this is the most common one, which is Kelvin to degree Celsius. It is by this correlation. For conversion from Fahrenheit to degree centigrade, it is nothing but 9 by 5 degree T in degree centigrade plus 32. Now this 9 by 5 is nothing but 1.8. So this is also correct one. Now this is degree Rankine, which is another unit to measure temperature. So this relation is also correct. However, degree Rankine to degree Celsius is related by this, and if we convert this into in terms of Fahrenheit, then this is wrong. So this is not the correct answer here. Now next question is, a pyrometer device is used for measurement of dash. So pyrometer is a device which is used to measure temperature from a distance. Um, Usually it is used to measure the temperature of very high temperatures where we cannot go physically, or for remote locations where we cannot go and measure, or the temperature is such a high that it is the another materials are not able to sustain. So say for example, there is one hot body at temperature T, so it will emit some amount of radiations. Okay, so this radiations, higher the temperature, higher will be the radiation. So we put up a lens here which will allow the radiations to converge, and it will add up here. So here the black body, it absorbs all the radiations and it will result in some amount. Now it will be measured, like what is the change. Now that change, or the what there has to be some quantity which needs to be measured, because for example, if this is some material and if it absorbs some heat, then there has to be some property which changes. So here in pyrometer, what we use is the voltage, because more the temperature, it will allow the voltage to flow. So based on the voltage, there is calibrated in terms of the temperature. So by this correlation and by this calibration, the amount of voltage that flows due to the electron transfer, electron movement, which is dependent on the energy of the radiations. So we measure temperature in terms of voltage. So here the correct answer is nothing but temperature. Next question is, match the following. So here first is heat transfer. So for heat transfer to take place, we need temperature gradient. For momentum transfer, we need change in velocity, and for mass transfer, we need change in concentration. So if we relate at minute scale, this delta can be represented in terms of d also, which is differential. So for heat transfer, delta T by delta X is in 2. Momentum transfer is correctly represented by equation 3. And for mass transfer, it is 1. So the correct answer here is B. Next question is, what is the correct unit for momentum flux? So any flux is represented by the quantity per unit area per unit time. So momentum flux will be nothing but momentum upon the area into time. The unit of momentum is nothing but mass into velocity divided by area A into time t. So now if we put up the units here, mass is measured in kg, velocity is measured in meter per second. Now divided by area is measured in meter square and time is measured in second. So the correct answer here is C, kg meter per second per meter square second. Next question is, heat is transferred from a wall having a thickness 2 mm by conduction only. So this is the wall having the thickness 2 mm. One side of temperature is maintained at a constant temperature T equals to 100 degrees Celsius T1, and another side is maintained at temperature T2 equals to 25 degrees centigrade. Now thermal conductivity K is 0.5 watt per meter Kelvin. You need to find out heat flux. So here in this lecture only I have given you what is the equation used to calculate rate of heat transfer, which is nothing but by conduction, which is nothing but Q dot is K A delta T by L. Now here Q dot is heat, like the rate of heat transfer. Now since we want to find out the flux, it will be nothing but per meter square. So this area comes out in the denominator. So Q dot by A is nothing but the heat flux is equals to K into delta T by L. Now if we put up the values here, so K is having value 0.5. Now since this delta T is just the temperature difference, the unit here doesn't matter, because if you convert it into SI, then T1 will be 100 plus 273 and T2 will be 25 plus 273. So at the end, since it is just the difference, 273 will cancel from both. So we can directly put up 100 minus 25. Otherwise, you need to take in care like which unit you are using. I will show where you have to take care for this. And length here given is 2 mm, like which is nothing but the difference between the 2 points where we need to measure. So 2 is in mm. So converting it into SI, it will be multiplied by 2 mm into meter. Sorry, it will have to be divided by, just a second. So here we need to divide so I guess so far it is clear. So I have put up the value of K delta T, and since this length is in mm, so to convert it into a meter, we need to divide this by 1000. So if we solve this and calculate, then the value comes out to be 0.5 into 75 into 1000 by 2 as 18750, which is watt per meter square. Now the options we have is in terms of kilowatt per meter square. So to find out in terms of kilo, we will divide by 1000. So 18750 by 1000 kilowatt per meter square, which is nothing but 18.75 kilowatt per meter square. So correct answer is 18.75. Next question is, heat transfer occurs by natural convection because the change in temperature causes the difference in for this question, earlier also while explaining the convection process, I had highlighted the like there is one phenomena which results in due to the change in temperature. So can anyone tell me what is that phenomena? So that is only the correct answer for this question. Anyone wants to answer? So if not, I had highlighted that the change in concentration the change in temperature causes, like if this is T1, which is much more higher than TF, which is the bulk temperature. So T1 is since higher, so the immediate contact fluid will have higher temperature and the far away will have lower temperature. So higher the temperature means density will be lower, and lower the temperature, density will increase. So this difference in density will result into the fluid which is upwards having lower temperature and higher density to come downwards, and the one which is in the contact with the surface having higher temperature and lower density to move upwards. So this will cause a bulk motion and it will cause natural convection. So the correct answer is density. Next question here is the Stefan-Boltzmann law expressed as where these are the constant. So what is that relation? It is used for the heat transfer through radiation. So the correct answer is Q equals to sigma epsilon A T to the power 4. So you need to remember this equation because it is the most basic one. Next question is, a black body of finite dimensions at 1000 Kelvin is inserted into an infinite medium at 300 Kelvin. Say for example, this is this infinite medium and this is the black body. It is having temperature T equals to 1000 Kelvin, and this is the external infinite medium. It is having T equals to 300 Kelvin. Now the Stefan-Boltzmann constant is this much. Find the radioactive heat transfer coefficient. So this question will be solved in two phases. So firstly, we need to find out what is the amount of heat that is transferred from this black body which is having higher temperature to the infinite medium. So for that we will use Stefan-Boltzmann law, which is sigma A T power 4, like delta T power 4. So here you need to take care that the temperature should be in Kelvin, because you need to individually um, take the temperature raised to power 4. So for SI unit, even if if you take in centigrade or so, then or there like it is not just addition or subtraction, so that it will automatically cancel out, as it was in the case of conduction. So here you need to take care that you will take the temperature unit as Kelvin only. So if you calculate Q, it is nothing but 1.8. Sigma is Stefan-Boltzmann constant, 1.8 10 raised to minus 8. Yeah, here area is not given, so you can take Q by A into 1000 power 4 minus 300 power 4. So if you calculate Q by A, it comes out to be, anyone is calculated? It comes out to be 17854.2, which is nothing but watt per meter square. Now this is the amount of heat that is being transferred from this black body to this medium. Here you need to find out heat transfer coefficient. So heat transfer coefficient is nothing but Q equals to HA delta T. Okay. So here H represents the overall heat transfer coefficient. So this you need to find out. Yeah, now you have the value Q by A, which was obtained from this equation, because due to this much temperature gradient, majorly the transfer of heat will be because of radiation. So Q by A you know, and you know delta T, which is H into delta T. So you will be able to calculate H. So H is nothing but Q by A is 17854.2 divided by delta T is nothing but 1000 minus 300. So if you simplify this, it comes out to be 25.5. So 25.5 is the correct answer. Next question is the unit of diffusivity. So diffusivity is calculated from Fick's law, which is J equals to, which is the flux equals to diffusivity minus dC by dx. Now if concentration is in moles or molar concentration, so this flux will be in molar per meter square per this length, like meter. Like this molar will be nothing but moles per unit flux is nothing but concentration gradient per unit length, per unit area, and per unit time. Actually, I have made some mistake. Just a second. So if you do the simplification, then the unit will come out to be meter square per second. The unit of J here will be moles per meter cube. There will be one more area here into time equals to dc by dx. So this also has unit moles per meter cube into meter. So meter cube get cancelled out, moles gets cancelled out. It has supposed to be meter square per second. I am a bit confused. Can someone even if someone understands, they can tell me right now, or maybe I will take up this later. I will simplify this and get back to you next time. So next question, which is the last question, is the unit of rate constant for first order reaction is. So first order overall reaction is A gives products. So rate will be represented as KCA. This is power 1. So if rate is nothing but dC by dt equals to KCA. Now dC by dt is moles per unit, like this is moles per liter into time, which is seconds. equals to K into moles, like the unit of Ca, moles per liter. So moles per liter cancels out, and the unit of K here is 1 by S. So the correct answer is 1 by S. So by this, the second assignment also is done. So if someone has any doubt, they can unmute themselves and they can tell me. Do you have any doubt? Anyone? Okay, so if not, I will end this meeting. Uh, we will meet next time in the next live session for the next assignment. And thank you, everyone. I am ending this meeting.